let's pull back the curtain on their technology that is, well, pretty much powering our entire world right now, from the phone in your hand to your favorite streaming service. Let's get right into it.
You know, it really does feel like magic, doesn't it? 1 second you'll look at your phone and it unlocks just for you. But it's not magic. It's an incredibly powerful computational model. And by the end of this, you're going to understand exactly how it all works.
Okay, so to really get to the heart of this, we need to zoom out first. We've got to understand the whole landscape, starting with the biggest concept of them all, artificial intelligence.
So think of AI as this giant umbrella. At its core, it's really just any technique that lets a computer mimic human behavior, anything from problem solving to learning. It's the big idea that covers everything else we're about to talk about.
A perfect example is probably sitting in your pocket or on your kitchen counter right now. When you ask Siri for the weather, it's not just following some pre-programmed script, it's actually using AI to understand what you mean and give you a useful answer.
Now, let's get a little more specific. Underneath that big AI umbrella, we find machine learning, or ML. And the keyword here, the really important one, is learn. Instead of a human programmer writing code for every single possibility, these systems learn and improve on their own, just by crunching a ton of data.
Think about your favorite streaming service. There isn't a person somewhere making a rule that says, oh, if they watch action movie A, they'll definitely like action movie B. No way. Instead, the system analyzes your viewing history and the history of millions of other people to learn patterns and predict what you'll probably enjoy next. That is machine learning.
And if we drill down one level deeper, we hit deep learning. Now, this is a super specialized, really powerful type of machine learning. It uses something called an artificial neural network with tons and tons of layers, that's the deep part, to find incredibly subtle and complex patterns in massive amounts of data.
So, let's just recap how this all fits together. AI is the big, overarching goal, making machines smart. Machine learning is a way to achieve that by letting them learn from data. And deep learning is a really powerful technique within machine learning that uses these complex neural networks, which, you guessed it, is our main topic for today. So let's do it. Let's look inside this digital brain. What in the world is an artificial neural network, or ANN?
Okay, the official definition tells us it's a model that's literally inspired by our own brains. It's built with these things called nodes, which are kind of like digital neurons, and they're all connected to each other in layers, and they pass signals back and forth to process information.
But honestly, the simplest way to think about it is also the most accurate. When you hear ANN, just picture a stripped-down digital version of a brain.
Here's another analogy I love. Picture the neural network as a big, busy city. The neurons are all the different locations, houses, shops, offices. The connections between them, those are the roads. As information or traffic flows through this city, the network starts to figure out which roads are the most useful. It basically widens the highways that lead to the right answer, making them stronger and faster.
So how does a digital brain actually learn? Well, it's pretty much just trial and error, a lot like how we learn. First, it looks at something like a photo and makes a guess. Is this a cat? If it's right, awesome. The pathways in the network that led to that correct answer are reinforced. They get stronger. If it's wrong, no big deal. It just adjusts those pathways and tries again. Now just imagine that process repeating millions or even billions of times. The network literally learns from experience, getting smarter and more accurate with every single guess.
And look, this isn't just some abstract theory. This technology is already completely woven into the fabric of our everyday lives, from the phone in our pocket to the local hospital.
AIs are working for you every single day. They're the reason your phone's assistant can understand what you're saying. They're what allows social media to automatically spot your friend in a photo. And they're the engine behind those recommendation systems that just seem to know what song or product you're looking for next.
And they're also protecting your money. Banks use ANNs to analyze your spending habits in real time, spotting a fraudulent charge sometimes even before you do. In the financial markets, they're digging through mountains of historical data, trying to find patterns to predict where stocks are headed. The stakes get even higher when you look at health and safety. We're talking about ANNs that can analyze medical scans like MRIs to find signs of disease that a human eye might miss. And they are the absolute core, the brain of a self-driving car, processing a constant flood of data from sensors to navigate the world safely.
And finally, ANNs are connecting all of us. Those real-time language translation services that feel like pure science fiction,
That's powered by ANNs that have learned the deep, complex patterns of human language. And the next time you're talking to a customer service chatbot, odds are you're interacting with an ANN that's trying its best to understand and help you out.
So, from our phones to our finances to our health, it's clear these digital brains are already making a profound impact. And that really leads us to one final, very important question.
Think about it. We've built these models that can learn from experience, a lot like we do. They're sifting through this giant ocean of the world's data to learn how to see, hear, and even predict what might happen next. So as they get more powerful and more integrated into our lives, the real question isn't just what they can do, but what we will ask them to learn next.